Our keynote speaker is John Mobies from Crate and Barrel. He's the Director of Construction for Crate and Barrel, and we're very happy to have him here. John is recognized as a leader in the use of internet-based project management tools, building information modeling, and digital document review to improve project performance. Before joining Crate and Barrel, John was an associate principal at Good, Fulton, and Farrell Architects in Dallas, where he oversaw the firm's development and use of workflow technology. Having worked also for Modern Continental Construction and Whole Foods Markets, he has experience in all sectors of the AEC industry. John received his bachelor's degree from the University of Massachusetts, his master's degree from University of Texas, and if you'll join me in giving him a warm welcome, we're happy to have John this morning.
Well, thanks for inviting me. I sort of want to say thanks 3 times. First for inviting me, thanks to you guys for attending, and thanks for listening to me and to everyone that you're going to hear today. A little bit more about what I do at Crate before we launch into some neat slides. I oversee the construction department at Crate, and we're essentially construction management at agency for Crate and Barrel. So we're not owners reps, we're more construction managers. And that sort of is going to inform my talk today about how we run projects, how we put buildings together, and where we see not only our industry going, but where we see the AEC industry going as well. I have sort of 4 parts to this. The first part is going to be about how we use Tekla and how we use BIM and how we do some interesting things with our buildings. The second part is going to be kind of a talk about models from our perspective at Crate, maybe a little bit of mine. And then the third part is sort of where we're working right now with respect to future development of the overall technology. And the last part is sort of what I call hope. So a little bit about Crate and Barrel. We were founded in 1962 in Chicago, headquartered just outside of Chicago these days in Northbrook. We have 168 stores in the US, Canada, and the United Arab Emirates, looking to expand currently into London, Singapore, and Chile. Foreign expansion is very big for us right now. And we're retailers of housewares and furniture, so it's what I colloquially will call spoons and sofas. And our emphasis is on people, product, and presentation. We're not a big box retailer. We're sort of a boutique retail, but we really want to focus on the customer experience, showing product that we find all over the world in a way that's very dynamic and very engaging. A little bit about how we build. If you looked at us as retailers, we probably have the most bizarre way of building buildings. We don't use prototypes. Every building is completely unique. Most of that's due to the real estate that we get from developers. Hard good retailers like us don't generate a lot of rent compared to apparel or electronics. So they tend to give us the vestiges of leftover land in malls, and we have to make them work. You know, sow's ears into silk purses. It's very hard. Each building is sort of inefficient in that respect compared to a Walmart or a Target where you can repeat buildings and make them more efficient. They're also very articulated. We like buildings that are very dynamic, very gestural. We think it complements the merchandise that we sell and creates an iconic building in the area that we're placing it. They're also very neo-modern. They don't have a lot of moldings. They have a lot of reveals. That's very hard to build because molding hides a lot of error. We have a lot of reveals that express error sometimes. And they're very difficult materials to source for us. We use custom stone. We use special wood that comes out of British Columbia. We use wood that comes out of New Zealand. So sometimes just getting the bulk of the material to the project site is probably our hardest effort. And our employees and our ownership are very, very sensitive to the building. They consider the building as a marquee to the brand. We have people at Crate that feel you should be able to take the sign off the building, and customers will still recognize the building as a Crate and Barrel building. I'm not sure I always agree with that, but it shows the level to which we take pride in our facilities. I'll show you a couple of pictures. Do a lot of 2-story buildings. You'll see a lot of angles, a lot of curtain wall, we've done some historic adaptations in New York City, Boston, and San Francisco that require a very different sort of expression. This is our only concrete building that we built in 2000 in Tyson's Corner. We learned a big lesson from concrete which is it's not very forgiving. And in retail, we like to change our minds a lot. We're like squirrels crossing the road. And we decided to go back to steel. And since then, we've only built out of steel. Another thing that's unique about us is the amount of light that we use. We have over a mile of track lighting in every crate and barrel, and we burn over 1,000 lamps in that track. And we move them around constantly. It's like a little theater inside the store because we refresh the product 4 times a year. We move it around. It's not a static operation like a drugstore or grocery store. So we need a facility with a lot of light, a lot of theater. Creates a lot of heat. You know, lighting in a typical building is about 20% of your heat load. In a crate and barrel, it's 60%. So we have the lighting system and the mechanical system actually of a small museum. And that has a huge impact on structure because, you know, as you all know, structure's coming down, ceilings are going up, so the coordination of everything above the ceiling is tremendously complicated for us. And we just sell spoons and sofas. We're not a museum. So we have economic pressures to do this very efficiently. And to be honest, in the boom years, what we call the golden age, from about the mid-90s until 2008, we could afford to do this. We didn't have to watch, our pro forma budgets too carefully. Most retailers were making very good money during those times. But after Lehman Brothers, we sort of woke up wearing our own barrel, like a lot of us, and we had to rethink things. And like Tekla, we were acquired in the mid-90s to early 2000s by a European company out of Hamburg. And they looked at our P&L and our bottom line in late 2008, so the end of the golden age. And they said, ein Minuten bitte. Things are looking not so good, and we're going to give you a survival mandate. So at the beginning of 2009, they said, Crate and Barrel needs to keep growing. It's your main revenue stream for growth, but you can't build buildings like you used to in terms of how you put them together and how you've spent money. In fact, you need to spend 30 to 50% less on a building, and you need to get it to market in about 45% less time because you're taking too long. So they're too expensive and they're too long. But we love the way they look, so keep the same look, And we said, okay. It's really, what choice did we have? We could essentially do a large corporate save as, put our whole development side, in the unemployment line, and wait until the economy comes back, and it hasn't really come back. Or we could figure out how to do this differently and keep going. So we're still building. And how we did this was to sort of, in a broad brush, challenge a lot of assumptions about construction, about design, about architecture, about engineering. We challenged everything. And that's a luxury that owners have. We can challenge things. Our old former owner said, it's the golden rule. He who has the gold makes the rules. So we could ask engineers to work differently. We could go find fabricators. We could mandate use of technology. We could rewrite contracts. We could, risk manage the job differently because we're the owner. And it is a tremendous luxury to do that. So we challenged a lot of design build assumptions. We looked for bottlenecks and constraints. It wasn't hard to find them. One thing that's interesting for me, I'm essentially in the AEC industry, but I'm also in the retail industry because I work for a retailer. And retail is extremely efficient. How you get product from a manufacturer to a distribution center, from the distribution center to the store, from the store to the customer, has to be studied, and it's studied to the most minute detail. And if you go to our shipping and logistics department or merchandise procurement departments at Crate and Barrel, they can tell you thousands of bottlenecks and constraints that they've conquered over the last 40 years. I realized in construction and architecture, we weren't really doing that. We weren't finding bottlenecks and constraints and eliminating them. We sort of just put up with them. So for about a year, we, what I call, bailed the boat. And we kept pace with the recession, but we also started throwing out a lot of bad water from our process. And really started leveraging the use of models. This is a current example of stores that we're doing now from 2010. This is in Pittsburgh. And essentially, everything's modeled. And I'll show you why in a minute. We've got essentially a design build model at the upper right for concrete, steel, deck. We've got civil engineering and landscape models at the upper left. MEP models at the lower left, prefabricated walls in the middle, and what we call a design intent model at the lower right. And we did this because we realized from about 2000 forward that there was value in modeling. Modeling prevented error. It prevented our error. That was the first thing we realized, was that when we modeled things as the designers of the store, we caught error. We caught things we didn't realize. It was much better than catching it in the field later and spending hundreds of thousands of dollars to correct the design intent. So we were strong believers in modeling to catch errors in design intent. We started telegraphing that into construction. Our best example today has been structure. And this is maybe an over-rendered picture of common structure for us on a building. And you can see the level of detail is probably about an LOD of 300, approaching 400. This is the fabricator's model and the engineer's model superimposed. They work together. They work in Tekla. And then they've modeled, the structure and part of the foundations, and actually an existing condition that we had to span over, which was a 36-inch sewer pipe, would have cost, it really would have broken the deal to move that, so we had to create a novel little solution to span over it. The level of detail that our models have hit now at the design levels, pretty interesting. We realized that we were losing value, so spending extra money, putting in detail late in phase. And if you look at this example, you all know what we're looking at the gusset plate, at the lateral load brace at the upper left. That impacts us sometimes, and the gusset plate's not shown in the engineering model. It's shown in the fabricator's model, but we may not catch that. And in this case, there was a curtain wall window projected for that corner. We would have missed the gusset plate in design, but since we are using a very high level of design definition early in our design process, we're able to catch it. So you had to find engineers that would use Tekla at a fabrication level of detail early on. And that's kind of tricky to do that, but it's been very, very successful for us. The savings is that with the right partnership of engineers and fabricators, you're not duplicating model time. And what we realized in 06 and 07 was that we had an engineer who was doing great work in Revit, very good modeling, but it wasn't interoperable with Tekla. So really the detailer was having to start all over again in Tekla, and that was about a $50,000 cost to us. So over time, we were able to, sort of knit together the structural engineer and the fabricator so that there's not that $50,000 cost of remodeling into Tekla. It's all seamless. We also learned a lot through our relationship with one fabricator in North Carolina about how steel is not only modeled and shown to us in drawings and in views, but how it's fabricated. And this was very interesting to us, I think, as an owner, as a retail owner, because we saw the potential for a lot of waste. And we started to understand that despite these pictures and what you see, steel fabrication has a lot of manual process to it. Adding clips and angles is done by welders, on the shop floor. And when you change something, the risk of them getting the wrong information at the wrong time is extremely high. And we actually took all of our project managers at Crate, all of our internal architects at Crate, and our outside architects and engineers, and over about 10 trips to Charlotte, walked these lines and understood how steel flows from the flatbed rail car to the truck after it's been primed. And really developed not only a respect for it, but an understanding of when we can save time without spending additional money. So we learned a lot, in our experience with Tekla and steel, which really started in about 2003, dabbling, and we kicked it into high gear in 08. Learned a lot and developed a lot of confidence with models. We took this confidence into other areas like drywall, and these are drawings of our interior store fixtures that for 30 years have been built out of some tube steel provided by Division 5, some drywall studs and drywall provided by Division 9, and finished carpentry provided by Division 6. So you have three major subtrades all working on site to build this fairly small little wall. We realized, well, if we can build structural frames with very little error anymore using the Tekla approach, why can't we do the same with interior drywall? And we started pulling these parts of the building out and design them very, very accurately with sort of this, nuts and bolts approach that we've seen Tekla detailers do, and turn them into fixtures. So this is just sort of built construction like you would see in this room, but we found fabricators who were used to building cosmetics cases and display cases for other retailers, and we asked them just to build walls for us, but use this level of detailing, right down to the screw, and actually designed prefabricated modular electrical systems as well. And the result is this, where everything that you see below that sort of white bulkhead where the lights are and the exit sign is, that's all been prefabricated and installed really in the last 5% of the construction duration. Because it's prefabricated, it's built with about 70% less labor in a factory. It's just easier to move material and people around and work efficiently in a factory than when you're trying to do it on a job site. And now we do almost every vertical surface that you would see in this room prefabricated. Here's an example of how we're doing exterior walls. We took that same learning that we developed with steel and interior partitions and quickly telegraphed it to the exterior of the building. These are exterior wall panels that have been put up over about a 5-day period on a store in Dallas. I'll point out an interesting thing. It took 5 days to install these walls. When we stick built them in the field, it would take a month and a half because you're always fighting weather and site logistics. And the contractor who's following our prefabricator here has to clad these panels. He has to put all the exterior materials on them. He didn't think we would finish in 5 days. We said it would take 5 days. It took 5 days. And as you notice, he's not mobilized. So when I saw this picture from the project webcam, I was actually kind of sad that we weren't mobilized on site. But I also was very happy that we had made our schedule. It's something to study, though, with prefabrication because it's a logistics puzzle that is trickier to achieve than it appears. So we actually had to speed him up a little bit. These wall panels are very interesting. The technology, where the technology is sort of headed, is fascinating. Several years ago, we saw panels being fabricated by studs, where people would buy studs from Dietrich or Merino Ware, and they'd just build them in a garage, and that was the idea of prefab. Well, it was just stick building in a building and towing it to the site, really. It didn't have a manufacturing logic to it. And now what we see with prefabricators is they simply buy coil stock, and they basically roll their own studs, roll their own pieces, all coming out of this sort of Tekla-based model that's very, very accurate in terms of piece count. Their waste factor is less than 1%. Compared to typical stud framing. It drives me bonkers when I go to job sites that we're not prefabbing, and you count the number of dumpster hauls that we've made just throwing scrap material away, compared to this process where there's very little to no waste. Again, it's assembled in a factory, very controlled conditions. Workers don't have to wait for a lift. They don't have to find material. They're not asking answers for an RFI. The 3 big reasons 30% of every dollar is wasted on a job site. And at the end, you can put them on a nice high cube truck, very dense pack, so it's very efficient to ship. And it fits nicely. I love this picture because it's got an excellent stud panel model. We had an excellent Tekla steel model. And look at how that panel was sawtooth to fit around those 2 beams. And they dropped it into place and it fit. And I wanted to see this. I don't, I let my project managers go to the job site more than I do. I went to this job site just to see this panel fit. And they didn't know I was going to just show up, and I took this picture, as sort of proof of concept that, when you're using good modeling, we have a good team, and you believe in it, you can achieve this sort of precision. The team sort of took it to another level where we were looking at our concrete costs, and a typical slab, 29,000 square foot slab on ground, was costing us about $400,000 to place. And we talked to the construction managers about this cost. We realized that a lot of the cost is in form labor for the slab. You have to form, the edges of the slab and then pour the concrete. Well, that's a questionable value when you think about it, because you're placing forms and then you're going to pour the concrete and you have to take the forms out. You could just call it, a high transaction cost. Then we realized, well, we've already prefabbed the walls, and the walls are following the same profile as the slab. So why don't we borrow a technique from tilt wall and extend the lower section of the wall panel down to a kind of a lean mud mat, something very simple, quick to install, and then let the prefabricated wall panels form the concrete. And so when we produce this, we've done this on 4 projects so far and are trying to patent it at this point, we cut our concrete costs by almost 60% because we took out most of the labor. There's still a little bit of form labor to do where we don't have those walls, but most of it's been eliminated. Before we started really implementing BIM and this sort of IPD design build-based approach with technologies like Tekla, this is a sort of order of magnitude that we were spending on a building. The gold represents what we were spending through sort of traditional process. And the blue represents what we were spending through sort of a design build or BIM-based process using models. This is what it looks like currently. So the blue is what we're using to high effect via models and BIM, and the gold is what's been left to sort of old school process. And this has been the economic result. So you can see when we really started focusing on this, in 2006, 2007, we were putting the pieces in place, but we weren't seeing an impact yet, I think largely because the construction industry wasn't working with us. They were still kind of treating BIM and things like Tekla as an oddity or a novelty. But the recession woke everybody up, and you can see the costs really start coming down after 2008. So right now, we're building at about a 1995 level of cost. In gross numbers before this, in 2003, 2004, buildings cost $10 million. Now we can build them for about $5 million. We also had the same impact on schedules. Remember our owners, were really after the schedule aspect of things, and sort of, let's say, pre-Tekla, a building from beginning to end took 88 weeks, to produce. That's the design, the procurement, the building, and the commissioning. 2010, we had that dropped to 56 weeks. 2011, we've dropped it to 32 weeks so far, just by mining more of that time out of the process.